this one, we are asked to factor r to the 8 minus 1. And for this one, we have to recognize, okay, we're trying to factor this. We've got an r to the 8, so at first that might scare us because we haven't factored anything with an r to the 8 before. But the idea here is, what does this kind of look like? Where have we seen two terms with a minus sign between? Maybe it's a difference of squares. Is there something that I could make something squared minus, and of course 1 is 1 squared. And maybe you can see that r to the 8 is the same as r to the 4 squared. So we can make this into a difference of squares. And a difference of squares, when we factor it, 1 will be plus, 1 will be minus. It's going to be 1 and 1. And then we would get r to the 4 plus 1 and r to the 4 minus 1. And then you feel good, I factored it, and move on to the next question. Or maybe you take the time to turn to the back of your book, because this is what I want you to do every single time, and check to see if your answer matches. And you turn to the back of the book, and it doesn't quite match. They've got more stuff. So then we look back at this. Could we factor this some more? Well, we don't have a sum of perfect fourths. We've got a sum of cubes. We learned that the other day. We don't have a sum of squares. We don't have a sum of perfect fourth formula. So this first one can't be factored anymore. But this one might be another difference of squares. In fact, it is, because r to the 4 is r squared, and we'd have 1 plus 1 and 1 minus 1. And then you'd say, yay, I'm done, and go to the next question. Or maybe you check the back of the book and see, does it match with what the back of the book says? And it's not quite right yet. And you look again, maybe I have another difference of squares. And the answer is yes. So we still have this one. That can't be factored any further. This one can't be factored any further. But this one is another difference of squares. R plus 1, r minus 1. And that would be considered factored completely, because there is no more difference of squares. Of course, if you want to get crazy, this isn't actually factoring it further. But if you thought, well, r is just the square root of r times the square root of r. So then I could have square root of r plus 1 and square root of r minus 1 and write that. No, this is why I did it in green. It was done at the blue, but you can play around with those things, and you will find as you go further in math, there will be times that, you might get something like x squared minus 5, which can't be factored, right? But now, if you think about square roots, well, you could, if you wanted to, because the rules don't change, if you wanted to, you could factor it with square roots. So you could have x plus root 5, x minus root 5. And if you think about how you solved, if we made this equal to 0, equals 0, and get rid of this 0. If that was your question, well, how did you solve this before? You'd have moved the 5 over and square rooted both sides. And when you did that, you had to remember to add the plus or minus, because your math teacher said when you square root both sides, you have to remember plus or minus. Now that I've factored it, what do I get? I get this one is my negative root 5, and this one is my positive root 5. And it's the same thing. So it's kind of neat that that works that way. If you really, really enjoyed this factoring over and over and over again with the difference of squares, and you like that so much, just change this number to 128. And you can go for a very long time if you'd like.